So now we jump into our next topic. Our next topic is basic programming concepts. Now, the process of data analytics involves some element of programming. We need to write code, and this code is in the language R. And so when we are writing code, it is important that we understand some simple, straightforward concepts associated with programming so that as you move through the MSBA program, you can use these concepts in the different classes where you actually have to write programmatic code. Be it in R, be it in SAS or Stata or whatever language you might choose, these concepts generally hold true. There might be slight differences uh, based on the language in terms of specific symbols, but the broad concepts are going to stay consistent across programming languages. Before we start jumping into learning about programming concepts, open up your RStudio environment because we're going to learn about these concepts in specifically R. These concepts apply across other programming languages as well, but since we're learning R in this bootcamp, I thought it'd be a good idea to learn about programming and programming concepts in the R environment. One of the first concepts that we're going to learn about is the concept called variables. Variables are temporary locations in a computer's memory that are used to hold data. Think of it as a manner in which data can be stored and manipulated in your program or script. There are lots of different types of data that are present that we use. Characters, for instance, that, like, let's say we want to hold names are characters. Numeric data, so let's say for instance price or age or anything numeric in data is another type of data. You might have integer data, that is whole numbers. You might have logical data such as booleans, and then you might have more complex data types. So there are different types of data that are present across programming languages and even in R. And what variables do are they're locations to hold these different types of data. Now, associated with variables, there is something known as the type of the variable. Um, Most programming languages are either strongly typed or loosely typed. And so let's start by talking about what a strongly typed programming language is. A strongly typed programming language is a language where you have a variable, and that variable is when you declare, when you define the variable, you tell the program, you tell the script, you tell the computer, in fact, that this variable can hold data of a certain type. Let's say, for instance, character, right? And what that program and what that programming language and what the computer is going to do is it's going to say that this variable can only hold character type data. Well, that programming language, that environment is a strongly typed environment. It's a strongly typed programming language, which means that you cannot store any other data type other than character data type in that variable that you have defined. And then there are other programming languages that are more loosely typed. Loosely typed programming languages basically allow you to change the type, the data type that is present in a variable. And and you can do this on the fly. So for instance, you can have name that holds character data, and in the next line you can change that name variable to then hold some other type of data, like say numeric or logical or boolean or some other type of data, right? And those types of programming languages are loose or dynamically typed. R is a loose or dynamically typed programming language, allowing you to change the data that can be stored in a variable and change the type of data that can be stored in the variable. In R, we use this concept of arrow assignment. And so when we want to set a variable to be equal to a value, we use arrows as a way to actually accomplish that. The variety of conventions that people use for variable names. In R, variables need to start with letters. They can include numbers, and only a dot and an underscore are allowed in variables names. No other type of special character are allowed in variables names other than dot and an underscore. Coming back to our RStudio environment. Before we jump into actually looking at variables, let me describe the RStudio environment that you are seeing in front of you right now. Remember, early on I mentioned that the RStudio environment has 4 broad sections. Well, to start off with, the first section is the code editor. The top left portion of the RStudio environment is the code editor, and this is where we write our RStudio code. I said the other section of the RStudio code where you see the results of your running of the code as the console, and that is below the code editor where the mouse is hovering right now. Where the mouse cursor is hovering right now, this is the console where we see the results of execution of code written in the code editor. The third part of the RStudio environment was the global environment. This is where you see the status of variables and data. And that is to the top right here, where we see the environment and we see the global environment. There are a couple of other tabs over here. And we might use some of these over time, but for the moment, we're going to be looking at the global environment right here, and right now the global environment is empty. And on the bottom right, we have the space that that allows us to see our local environments. And so if we click on the Files tab, we can see our current local environment. We can click on the Plots tab down here. We can see any plots that we might have created. Click on the Packages tab right here. We can see the current packages that are installed. And these, again, if you remember, packages were basically what allow you to extend the features and functionality of R. We have also our help window. And so here are the different aspects of the local environment that we can view in RStudio. And so broadly speaking, these are the 4 components of the RStudio environment. So to start off with, let us take a look at variables. Now, before we take a look at variables, one important thing when we are writing code is to describe the code that we are writing, right? And so sometimes we like to take notes, and the best way to take notes is as you are writing code, you can take notes in the code that you are writing. So R allows us to do that through the use of comments, and the way we can write comments is by using the hash. The hash allows you to write something like this. And so anything that is preceded with a hash to R is a comment and is not run or is not considered executable in any way, right? And so if you want to take comments on code, if you want to comment your code as you're writing, which is good practice, which is going to help you collaborate with others as you'll work on group projects, commenting your code is going to be very important, and this is the way you do it. Now, once you start writing R code, we want to actually save this somewhere. The way you do that is you can click on the Save button right here, Save Current Document. You can also click on File, Save. And so I'm going to save the current document. Now, if I click on Save, it is going to ask me where I want to save it. Now, I can save it to any location I want. Now, so for instance, let's say I click on Save Current Document, and I'm going to go to Teaching MSBA summer 2020, and I'm gonna give this a name. For instance, intro to programming.r. So let's talk about variables. If you remember from the previous slide, variable names start with letters, can include numbers, and only dot and underscore are allowed names. And so a variable name like this, for instance, var1, would be valid. And so var1 is a variable name, and we might want to assign this variable name a value. Now, to assign a variable a value, we can either use an equals to or an arrow assignment. So I can either say variable 1 equals to 2, or I can do the following. I can say, now please notice that I put a hash over there, so anything I type off the hash is going to be considered a comment. And so I can say something like this, var1, and that is arrow assignment, right? So either of those two would be appropriate as a way to assign a variable a value. The variable name has to be present on the left-hand side, and the value that is being assigned to the variable is present on the right-hand side. To execute this line of code, we would need to do the following. You can either go to code and click on run selected line, and notice that when that line is executed, it is executed in the console, and notice we have a change in the global environment. In the global environment, we have a variable 1, that has a value 2 assigned to it, right? And that line is also present down here. Now, variables are case sensitive, and so I can declare lowercase var1, or if I can declare another variable var1, and this time I want to use arrow assignment equal to 3. Now, again, I can click on code and select run selected lines, or if you are on a Macintosh, if you hold the command button down and hit enter, you will execute that line where your cursor was. If you are on a Windows machine, you can hit Control Enter with your cursor on the line, and you will execute that specific line. And so notice that variables are in fact case sensitive, where lowercase var1 is different from uppercase var1, right? And so we have two variables, var1 and var1, assign values 2 and 3 respectively. Now, you might think, well, can I flip this? In the sense that, can I say 2 equal to var2? For instance, 2 equal to var2. Again, the thing to keep in mind is that in this case, if you set 2 equal to var2, that is actually not going to run, because you have to do left-hand side has to be the one where you do the assignment. So you should have var2 equal to 2, and you can't do 2 equal to var2. But what you can do is this. You can use arrow assignment to assign to variable 2, right? And so when you are using the equals to operator for assignment, you can't do 2 equals to var2, but when you are using arrow assignment, you can set var2 to be the value 2. And so we can comment and say, that line will not work due to left-hand assignment, but you can do 2 equal to var2. That'll work just fine. Now, there are lots of other things that we can do. For instance, we can have variables store data, for instance, and this can be different types of data. For instance, I can have, just to demonstrate the fact that variables are dynamically typed. I'm going to change the value of var1, and I can say this is a string, and if I execute this, you can see where var1 has gone from having the value 2 in global environment to this is a string in global environment. Now, again, when you see these changes, you might not actually see me doing this, but I'm actually executing each line as I type it out. I'm executing each line. Now, if you want to execute more than one line at a time, you can actually do that as well. Let's say I want to execute all of these lines that I've just typed out, but these lines have already been executed. But what I can do is I can clean out the global environment. If you see this broomstick over here under the global environment, the broomstick where my cursor is right now, and if I click on the broomstick, it says, "Do you want to remove all the objects from the environment?" And if I can click on yes, it clears out my environment. And so let's say I want to run everything that I've typed out over here. I can select the lines of code that I want to run, and I can click on this run button right here, right? And so you can see it has run the first comment, the second comment, var1, var1.3, gave me the error once again since it's not going to work, allowed me to set var2 using arrow, the arrow operator, and then change var1 to be this is a string. Now, there are lots of, and so the thing to note is if you actually want to store character data, you want to have the character be in quotes, right? Now, what type of quotes do you use is actually up to you. In this case, the first example for var1, I used single quotes, but I can also use double quotes. I can also use single quotes and say, right? And so you can either have, you can declare a string with single quotes or double quotes. And sometimes you actually might want to have a quote within a string. For instance, now notice that I can use either single or double quotes within a string if I use the other type of quote to enclose a string. So if I want to use a single quote within a string, I enclose the string in double quotes. If I, on the other hand, used a single quote, the other single quote would close the string out, right? And so depending on what kind of quote I actually want in a string, I'd enclose the string within the other type of quote. And so this allows me to put a single quote within a quote, within a string, when the entire string is enclosed by a double quote. There is one other way to do this. So if I want a single quote within a string enclosed by single quotes, if I use the backslash character and then the quote, I can do that too. And what that does is it allows me, the backslash character is known as an escape character. So I'm escaping that single quote. And so you don't see the backslash character under variable 5 over here because I've escaped. I mean, it's known as an escape character, and so basically it considers the single quote as just text and not part of the actual code. Now there are other types of variables that we can declare, and lots of other data types. For instance, in this case, I have var6 holding a Boolean value true, right? And just like it can hold true, I can have I can have it hold other values, in this case false. I can have variables hold more complex values, right? So I can have variables hold more complex values if necessary, right? And so this is just a little bit about variables and variable storage.